So in this problem, we have a truss system, but we only want to find the forces in members CD, CH, and HI. Now if we want to use the method of joints, we're going to have to start somewhere where we already can identify the forces and then just start moving, along the joints. So for this problem, I want to use specifically the method of sections. Now for the method of sections, we can't skip out on finding these reaction forces. Okay, so my first step for the method of sections should be to draw a free body diagram. If I look at this, I have a more or less simple truss system. You don't have to worry about your free body diagram being to scale, okay? Just since the test is timed, just do whatever the best you can, but it doesn't have to, your drawings don't have to be perfect. Alright, so I have this free body diagram. Here I have a hinge that's on a roller. So what are my reaction forces at F?
Normal forces pointing up?
Exactly, only a normal force that's pointing up, so I'm going to call this Fy. Here I have a hinge that's fixed. So what are my forces?
The forces in the X and the Y direction?
Yep, a force in the X, I'm going to call, and a force in the Y direction. I'm going to call my force in the X AX. I'm going to call my force in the Y AY. And then I also have a couple extra forces. I have a 40 kilonewton force, a 50 kilonewton force, a 30 kilonewton force, and a 40 kilonewton force. Alright, so that was step one. Just draw the free body diagram. My second step should be to find all the reactions. Okay, we skipped this in the other one, but since we're going to do method of sections here, we can't skip it here. So I want to find all the reactions. I want to find my AX, my AY, and my FY. So if I do sum of forces in the Y direction, I'm going to end up with two unknowns, so I can't use that. So what should I use instead?
Sum of moment.
Exactly, sum of moments. In this case, I want to eliminate as many unknowns as I can. So I'm going to take my moment about point A. That way I can eliminate these two unknowns. So I say that my sum of moments about point A equals 0. And let's see, what do I have? From point A, I have this 40 kilonewton force, which we know is acting at a perpendicular distance of 1.5 meters from your hinge. So I have 40 kilonewtons times 1.5 meters, and it's causing a counterclockwise rotation, so I'm going to say that it is positive. I have a 30 kilonewton force that's acting at 1.5 plus 1.5, that's 3 meters from the hinge. Also counterclockwise rotation, so I'm going to make it a positive force. This 50 kilonewton force, if you draw the line of action of the force, is actually going to go straight through the hinge, so it doesn't cause a moment, so we ignore it. And we have a 40 kilonewton force. That's acting at a distance of 2 meters from the hinge. Again, counterclockwise rotation, remember the steering wheel, so we have a positive value. And finally, I have my force in the Y direction, which is my unknown. I'm going to write it here. And that force is acting at 4 meters. The rotation here is clockwise, so I'm going to give my force a negative moment value. This should be equal to 0. So we have this big equation for moment, but only really one unknown. So I can just solve for my force Fy, and I'm going to get that Fy equals 57.5 kilonewtons. Okay? Now that I have Fy, I can solve for A1 and Ax easily by just applying sum of forces in the x or sum of forces in the y direction. So I'm going to start with sum of forces in the x direction. In the x direction, I have a 30 kilonewton force in the negative x-axis, so minus 30 kilonewtons. A 40 kilonewton force in the negative x-axis, so minus 40 kilonewtons. And my unknown force Ax in the positive x direction, so plus Ax. Those are all my x forces, so all this should equal 0. And I get that Ax is equal to 40 plus 30, 70 kilonewtons. And now I can finally use my sum of forces in the y direction. So sum of forces in the y direction equals 0. In the y direction, I have my Fy, which I already found, 57.5 kilonewtons. I have negative 40 kilonewtons, negative 50 kilonewtons. And I have an unknown force Ay, and I'm assuming that it's positive, so I'm just going to give it a positive value, plus Ay. And all this should equal 0. We only have one unknown, so we can solve for that Ay. Ay should be equal to 50 plus 40 minus 57.5, or just 32.5 kilonewtons. Any questions with this part of the problem, finding the reaction forces? All right, go ahead.
Okay. So the hinge, since it has two reactions, reaction in the x and y components, is best to find the moment about A to begin with, because we can eliminate those two forces that we said at the beginning, right?
Yes, yes.
So when we eliminate those, we only end up with a force in the y direction, right?
Yes.
On F.
Yep.
So when you say, the thing that confuses me when you say moment about, now the moment about the A axis is what we're looking for, right? So that means we take out all the forces that would push the rotation around the A axis, right?
Yes.
So we got 50 kilonewtons going. That's our line of action, right? In the y direction.
Yep. If I draw my line of action for 50 kilonewtons, it's gonna go through A. So really, there is no rotation.
All right.
So if you look at the steering wheel, then you can't really rotate the steering wheel.
Oh, absolutely. Okay. Sounds good. Thank you.
Yeah, no problem. So this was just the first part of the problem. But really what we want to find are the forces in these three members. CD, CH, and HI. Now, when you want to use the method of sections after you found your reactions, your third step should be to make a cut. And the question is, where do you make a cut? You always want your cut to go through your three members, okay? So in this case, my three members are going to be CD, so I want to make sure my cut goes through this member. CH, so I want to make sure my cut goes through this member. And HI, so I want to make sure, oops, I didn't draw this correctly, this is I. And HI, so I want to make sure my cut goes through this member. So I can just draw my cut roughly like this. Just make sure that it cuts whatever you want to solve for and nothing else, okay? So in this case, I want to solve for the forces on these three members. So I want to make my cut at these three members. If I were to do it in the free body diagram, my cut would go like this. Now why do I do that? Once I take that cut I'm going to have a more simplified portion of the truss that I can use. Okay, so if you still have questions on this, then just remember your cut has to go through your members of interest. Okay, so I want my cut to go through all these. It doesn't have to be a straight line. In fact, it doesn't even matter if I cut here or here or here, because the tension should be the same regardless of where you're cutting in this bar. The tension or compression should be the same regardless of where you're cutting in this bar and regardless of where you're cutting in this bar. So I can cut it right down the middle. I can cut it maybe closer to the joints, and just wherever you want, but at this section. Okay?
All right.
Now, what that's going to leave me with is a free body diagram which has less members. Now, I want to use the bottom part of this free body diagram. So just for simplicity, I'm going to draw it again. Essentially, my new cut system will look something like this. I have the bottom part, I have these members, and then I made my cut going through this member, and this member. So my free body diagram will have the forces, AY, which was 30, go ahead, AY, which is 32.5, AX, which was 70 kilonewtons,
Professor, on the practical exam, it asked for DH and not, let's see,
not CD?
not DC.
Oh, okay.
Yeah, it asked for DH, HC, and HI.
Awesome. So that means that the cut should go through these three for the practical exam. Okay?
Yeah, that's right.
Yeah. I'm already starting to solve this, so I'm just going to solve it. The procedure would still be the same. Okay? But I'm going to finish this one since I already started this one. And what I'll do is I'll just record the one from the practical exam and then upload it tonight. Okay? So when I cut my members, I'm going to end up with an unknown tension or compression force here, an unknown tension or compression force here, and an unknown tension or compression force here. They're unknown. I don't know if they are in this direction or in the opposite direction, but it's okay, because if I get a negative value, that just means that the arrow should go in the opposite direction. So this force goes from C to D, so I'm going to call it force CD. This one goes from C to H, so I'm going to call it force CH. And this one goes from H to I, so I'm going to call it force HI. You can call it HI, IH. I usually prefer to call them in alphabetical order, or name them in alphabetical order. But yeah, this is basically what my new free body diagram looks like after I make the cut. Okay? So I still have unknowns, so I still have to solve them. But after I make my cut, which was step 3, then my final step should be to apply the equations of equilibrium and then just solve this problem. Okay, so I can use sum of forces in the x direction, sum of forces in the y direction, or sum of moments. In this case, I have a bit of a problem. If I use sum of forces in the x direction, I'm going to have 2 unknowns. If I use sum of forces in the y direction, I'm going to have 2 unknowns. And if I join those 2 equations, I'll have 3 unknowns. So it'll be 2 equations with 3 unknowns. That doesn't work. So if sum of forces does not work, what's my alternative?
Moment.
Exactly. You want your sum of moments. When you're selecting a point where to take your moments, from which to take your moments, you always want to select a point that can help you eliminate as many forces as possible. So in this case, this is my point C. Let me see. Yeah, I think this was C. A, B, C. This was I. So in this case, if I were to select my point C, I'm eliminating 2 unknowns and only ending up with 1 unknown. So I can take my sum of moments about my point C. Okay? Equals 0. Now I can see which forces are causing a moment about point C. Looking at this, I have this unknown force HI, so force from H to I, which is unknown. and that is acting at a perpendicular distance of 2 meters from my point C. This is causing a clockwise rotation, so I'm going to give it a negative value. And then I can just look at all my other known forces. I got 40 kilonewtons at a distance of 1.5 meters from my point C, causing a clockwise rotation, so negative. And then I have 70 kilonewtons at a distance of 1.5 plus 1.5, that's 3 meters. And that's causing, about point C, it's causing a counterclockwise rotation. So I'm going to give it a positive value. And finally, I have my 32.5 kilonewtons acting at a distance of about 2 meters from point C. And that's causing a clockwise rotation, so negative value. And all that should equal 0. So, take this, solve for my HI. And this gives me a force from H to I of 42.5 kilonewtons. And it's a positive value, so it's in tension. So that means I assume this direction correctly. Now to answer India's question, if I want you guys to identify them as tension or compression, you can just write parenthesis T. Okay, that should be an easy way to identify them as tension or compression, but just with this diagram, that is enough to let me know that it's in tension. Okay, so I found my HI. I still have to find my force from C to H and my force from C to D. Again, I want to make sure I can eliminate as many forces as possible. So here's a little bit of a trick when you're doing method of sections. When you take your sum of moments, even though you're looking at only a section of the problem, you know that this truss will have this shape. Even though we're only studying a section, we can still take the sum of moments about a point that's not in this section. So in this case, I want to find my force from C to H. Okay? So if I want to find my force from C to H, I can find that force by using sum of forces in the x direction, or I can also find that force by taking a moment about point D. Now whichever method you choose, that's up to you. Personally, I would find it using my sum of forces in the x direction because that's easier. But there are some problems from the book where that's just not possible because you end up with a lot of unknowns. So if that happens, it's always okay to take your sum of moments about a different point. And why do I choose D? If I choose my point D, I can eliminate this force, and I can also eliminate this force. So I only end up with one unknown, which is my force CH. So taking my sum of moments about D, again, you don't have to do this for this problem. You can use X and Y, but I want to make sure that you have all the options in case the problems you see in the book do not allow you to use X or Y. So if I take my sum of moments about point D, this force gets eliminated, this force gets eliminated, I have my force CH, and that force CH is acting at a distance of 1.5 meters from my point D. It's causing a negative rotation. I have 30 kilonewtons also acting at 1.5 meters from point D, also causing a negative rotation. I have 40 kilonewtons acting at 1.5 plus 1.5, that's 3 meters from point D, also causing a negative rotation. Is that everything? No. I have 70 kilonewtons. Acting at a distance of 1.5 plus 1.5 plus 1.5, that's 4.5 meters. And that's causing a counterclockwise or positive rotation. And all that should be equal to 0. I can rearrange to solve for my force CH, and I'll get that my force CH is equal to 100 kilonewtons. Positive value, so I assume my direction correctly, which means it's in tension. Now you don't have to go through all this for this specific problem. You can just take your sum of forces in the x direction. You'll get positive 70, negative 40, negative 30, negative CH, and then solve for CH. You'll still get 100 kilonewtons. Okay. So, any questions so far before we solve for that last force?
Yeah, I got one question.
Yeah, go ahead.
Okay, what threw me off was that force CH.
Yes,
right?
sir.
Now, that's because it's a member. I mean, that's a joint, right? Well, that's a member, right? CH.
Yeah, this is the member CH from here to here.
Yeah, see that 30 kilonewton force acting along that member is what always seemed to throw me off, because force 1 meters, and then we also adding the 30 kilonewton force at 1 point.
Yep. So this 30 kilonewton force is an external force. Okay. So it's not part of the internal force of this member. So when I take my moment about my point D, I'll have my internal force, which is my CH, and to that I have to add whatever external force I have. Okay? Since they both act in the same direction, then they'll both have that 1.5 meters distance from the hinge. Does that make sense?
Yep.
Okay. Good. And finally, I can solve for my last force, and this should be my last one because I have a review session for fluids now. But I can just solve for that last force, which is force CD. CD, is it? Yeah, force CD. I can solve for this force by just taking my sum of forces in the y direction. Because notice that I already know this one, which means that I only have one unknown, which is the y component of CD. So if I take a sum of forces in the y direction equal to 0, I have the following forces in the y direction. From bottom up, I have 32.5 kilonewtons positive. I have my force HI, which I already found to be 42.5 kilonewtons, also positive. And then I have the y component of this force CD. So this y component has to follow the slope for this bar. Now I'm going to draw the triangle here. We had an x displacement of 2 meters and a y displacement of 1.5 meters. So 2, 1.5, this is a 3, 4, 5 triangle, which means that the hypotenuse should be equal to 2.5. If you don't know that, that's okay. Just use Pythagorean theorem, and you'll get that the hypotenuse is the square root of 2 squared plus 1.5 squared, which should give you 2.5. Okay, so I can write down my component. It's positive because it's pointing upward. I have my unknown force CD, and I multiply that by the slope. In this case, my slope will be 1.5 divided by 2.5. And that should be equal to 0. I solve for force CD, and I get that that force is equal to negative 125 kilonewtons. Now what does this negative mean for force CD?
We assume the direction wrong?
Exactly. That means that the direction for this force is actually going to be in compression, not in tension. So you can change the direction of the arrow, or you can just write this as 125 kilonewtons in compression, parentheses C. So those are the three forces for the three members. We got 125 for CD, 100 kilonewtons for CH, and 42.5 for HI, two of them in tension, one in compression. Are there any questions before we close this session?
Yes, I got one more question. So the exam is tomorrow, right?
Yep.
Okay, cool.
So it'll be open all day. So you can just open it at any point during the day, but once you open it, you got to submit it before the time limit.
Okay, sounds good.
Yep. I'm going to stop.
I have another question.
Yeah, go ahead.
So how do you submit the, when you're done with everything, you want to submit it to your email or through the test itself?
You can do whichever is easiest for you. So you can click submit through the test and it'll just submit everything you uploaded there. But if it's easier for you to take a picture and send it over email, then do that as well.
Okay.
Yeah, I'm going to keep track of both, the email and the testing app.
All right, thank you.
No problem.
Thanks a lot, Professor.
Yeah, no problem.